Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of CSC Data Science in Institute of Aeronautical Engineering. So in this video, I'm going to discuss about various examples of graphs. So in previous video, I discussed some of the graphs like bar chart, pie chart, line chart. So for taking an application, how I'm going to draw, so I'm going to cover in this video. So in this video, I'm going to discuss what is the data and what form it will be actually. So the data will be in a raw form. So this data will usually not easy to make decisions. So normally the data will be in raw form. So it will be difficult to understand what it is, right? So for that, what I have to do, I have to organize the data. For that, the organization of data will be of two types. So first one should be either in the form of tables or in the form of graphs, and then later I can able to convert this some other fashion or some other way by make use of these techniques. So first thing is ordered array or stem leaf display and frequency distributions and histograms, bar charts, pie charts, and contingency tables. So these are some of the techniques that are available for uh, uh, reviewing the data what we are going to be organized. Then tables and charts for numerical data is going to be classified into two types. So first one is ordered array and second one is frequency distributions and cumulative distributions. So if I'm going to consider ordered array, so the ordered array should be done through stem and leaf display, and frequency distribution and cumulative distributions that can be done through either histograms or polygon or ogive. So these are some of the techniques that are available for making this frequency distribution, cumulative distribution. So let's consider the first thing, that is ordered array. So what is ordered array? So ordered array is nothing but it should be a sorted list of the data, and the data is going to be arranged in min max to max and maximum to min, and we have to provide some signals about the variability within the range, and then should be help to identify the outliers, that should be unobservable observations. And the data, if the data set is large, what will happen? The order array is less and then useful, right? So the sorted list of data, so that should be done so within the range, that should be min to max, and then we have to provide some signals about the variability within the range and should help to identify the identifiers. So identifiers are nothing but unobservable observations. And if the data set is large, so the ordered array is less useful. So let's take the data in the form of raw, what we collected. So this is the data, assume it, and this data is going to be displayed in ordered array. So for that, what I have to make it in from smallest to largest. So initially we are having 24, 26, 24, right? So find out the minimum one. So that is the first thing, 21, and then 24. Then after that, what is the next minimum? That is 26, and next minimum is 27, and then 30, and then 32, 38, and 41. So, and the next thing is that the stem and leaf diagram. So it is another way of representing the data set. So here the data, the method here is we have to separate the sorted data series into leading digits, so that should be stems, and then trailing digits, that should be leaves. Okay, so this is this way of representing the distribution tables in the data set. So the method is that we have to separate the sorted data into leading digits and then trailing digits. So the leading digits what we called as stem, and trailing digits what we called as leaves. So let's take an example. So the data what I have taken previously, that should be taken again. So here, so what is the here I'm going to use 1/10th digit for the stem unit. So for that, what I have to do, take down the first one, that is 21. So the 21 is going to be represented as 2 as stem and 1 as leaf. So this should be trailing one. So the trailing is going to be written in leaf, and then leading digits what I'm going to written in stem. Okay. So next one is 38. Suppose I'm taking here. So 38. So 3 is going to be taken as stem and 8 is going to be taken as leaf. So like this I can able to construct this stem leaf by considering this sorted data. So on the way I'm going to represent completed stem leaf diagram. So how to make it, right? So let's take left column as stem and then right column as leaves here. So take down the data. So what is the stem we are having? Initially 2, and then 3 we are having, and 4 once we sort the data, right? So then write down the stem 2, 3, 4 here, and the stem, suppose if I'm going to take 2, so what is this number so I'm taking, right? So that one is going to be useful, that should be followed by to that stem. So that is 2, 1, 4, 4, 6, 7, 7. So that should be followed by stem 2. These are the trailing digits followed by the stem 2. Similarly, if I'm going to take 3 here, so the digits will be 0, 2 and 8, right? So that one should be the leaves of the stem 3, and 1 should be the leaf part of the stem 4. Like this I have to construct the stem and leaf diagram from the sorted data. Suppose if I'm going to consider them 3 digit as the stem, so what I have to do is, so first we have to round off the 10 digit to form the leaves. So 613 I'm taking here. So for that what I'm going to do is, so 6. So 6 should be the stem here, 7 should be the stem, and 2 digit number, so 12 should become the stem here. Then what should be the leaf? The leaf should be 1, and then I can able to write leaf as 8 and then 2 here, right? So like this I can able to represent this 3 digit stem and leaf form. So let's see the example here. So I'm taking that 100 digit as the stem. So how to represent in stem leaf diagram? So 613. So what are the stems we have? First to identify 6, 7, 8, and then 9, 10, and then 11 and 12. So first write down all the stems of what we identified this, and after that I write it. So what are the leaves that is going to be followed? So suppose if I'm going to take 6, so what are the leaves should be? So 1, 3, and then 5 or 8, 6, whatever it may be, you can able to write it. Similarly, if I'm going to take 7, so what I have to do? So 2, 5, 7, like this I can able to write. So like this I can able to construct this stem leaf by constructing the 100 digit number also. And then tabulating numerical data, so that should be frequency distribution. So what is the frequency distribution here is, so the frequency distribution is the list or the table, so it should able to contain the class groupings, so the categories or the ranges within which the data falls, right? Class groupings, and then the corresponding frequencies with which the data falls for each grouping or category. Right, so what is the frequency distribution? The frequency distribution is the list or table, so which can able to containing the class groupings. So the class groupings are nothing but the categories or the ranges within the data falls, and then the corresponding frequency with which the data falls within each grouping or category. So the frequency distribution is the way to summarize the data. The distribution condenses the raw data into more useful form and allows for a quick visual interpretation of the data here. So frequency distribution is the way to summarize the data, and then the distribution condenses the raw data into more useful form, and then which can also allows for quick visual representations of the data. Each class groupings have the same width. Suppose I am going to construct this class intervals and class boundaries. So each class group should have the same width, and determine the width of the each interval by the following equation. So width of the interval should be range divided by the number of desired class groupings, and then use at least 5 but not more than 15 groupings. So the class boundaries never overlap, and then round up of the near interval width to get the desired end points. Okay, so what is this class intervals and class boundaries? So class intervals is nothing but the grouping of the class should have the same width, and each interval should be determine by range by number of desired class groupings, and then we have to use at least 5 but not more than 15, and the class boundary should never overlap. So round up of the interval width to get the desired endpoints. So let's take an example here. So manufacturer of insulation randomly selects 20 winter days and records the daily high temperature. So this is the temperatures I got from the manufacturer of insulation. So 20 winter days I'm taking. So for that, this is the data I've got it. So 24, 35 degrees centigrade, 17, 21, 24, 37. So like these are the some of the degrees centigrades what I got it. Then what I have to do is, so first I have to arrange this data in ascending order, right? So once the data is going to be assigned, so find the range. So how I can able to get the range here? So maximum minus minimum value. So what is the maximum? 58 and minimum is 12. So if I'm going to subtract it, so what will get? I get 46. Then select the number of classes, so that is 5. So usually between 5 and 15. And then compute the class interval width. So that should be obtained by 46 divided by 5, should be rounded off. And determine the class boundaries limits. So 10 by taking this, so add it, so 10, 20, 30, 40, 50 and 60, and then compute this class midpoints. So what should be the class midpoint of each interval, that is 15, 25, 35, 45 and 55, and then count the observation and assign to the classes. So these are the steps you have to be followed before constructing this frequency distribution. So first, what is the data I'm getting? So that one should be take it out, and then we have to be arrange it in sorting order. And then next, what you have to do is, so you have to find the range. So how the range is going to be obtained by subtracting the maximum value to the minimum value. So that 46 is the getting, and then the number of classes, that should be 5. So usually between 5 to 15 you have to maintain. And then the class intervals, so how much it will be get. So dividing, so the range going to be divided by 5. So I'm getting 10. So that should be the class interval width, and determine the class boundaries with that width. So 10, 20, 30, 40 is going to get, and then calculate the class midpoints and then count the observation assigned to the class. Then, so data in ordered array. So data in ordered array. So once the same thing I'm taking here, and then write down the classes. So 10 but not less than 20, and 20 but not less than 30, and 30 but not less than 40, and 40 less than 50. So the frequency distribution is going to be calculated. So the frequency distribution values. So 10 to 20, how many values are there? So what is the frequency between 10 but not less than 20? So that is, we're having 3 values here. That one, write it here. So 20, next class is 20 but not less than 30. So up to this. So 1, 2, 3, 4, 5, 6, 7, 6. So 6 I have to take it here. And then 30 less than 40. 1, 2, 3, 4. Right? And 5. This one also I have to consider, right? So 5. So like this, I have to calculate this frequency values, and then relative frequency is going to be done. So how the relative frequency is going to be obtained? So 15, 30, and then 25. So these are the relative frequency. That is right, and the percentage how to write. So percentage should be 15%, 30%, 25, 20, and 10%. Right. So then what will happen? So we have to get the percentage. So that should be total should be 100 here. Right. So like this, I have to construct the frequency and relative frequency. So based on, and then calculate the percentage. So like this, I have to calculate the frequency distribution table. So next, histogram. So how to construct the histogram here. So a graph of data and frequency distribution is called as a histogram. So the graph of data, so in frequency distribution called as a histogram, and the class boundaries, or I can able to call it as class midpoints, are going to be shown in as horizontal axis, and vertical axis is either frequency or relative frequency. and then the bars of the appropriate heights are going to be used to represent the number of observations within the each class. So the class boundaries and class midpoints are going to be shown in horizontal axis, and then the vertical axis is either frequency or it may be a relative frequency or percentage. So the bars of the appropriate heights are going to be used to represent the number of observations within each class. So like this, I have to consider the histogram. So histogram is going to be constructed. So this is the table what I get from frequency distribution. So from that I have to draw a x-axis and y-axis and maintain this class intervals, that is 0, 10, 10, 20, 30, 40, 50 and 60, and midpoint should be 5, 15, 25, 35. And class midpoint should be taken on x-axis and frequency are going to be taken on y-axis. So in between 10 and 20, so in between 0 and 10, what will happen? Nothing is there. And 10 to 20, how much? So the frequency is 3. So write the bar. And then comes next is 20 to 30. So the frequency is 6. So 20 here, 30 here. Draw the bar. It should be the frequency is 6. So fix, we draw it. And 30 to 40. So 5. So these bars are going to be drawn without giving any spaces. So if you are going to give spaces, then it should become bar graph. So without bar space, that should become histogram here. So similarly, next 40 to 50. So what is the frequency here? 4. So like this, how to construct the histogram, right? So how to construct this histogram in Excel, I will explain now. So open this Excel and then click on the tools, and then under that the last field what we're having is data analysis. So click on that, and then next we have to select this histogram option. And next, so once you click this histogram, so what will happen is, so you can able to get one window here. So here you have to give the input range, and when bin range you have to be give, and then click on the chart output here. So once you click this, then you can able to obtain this histogram. So these are the ways I can able to generate the histogram from the Excel. So next, what are the questions I can able to obtain from grouping data into classes? So how wide should each interval be? So this is the question normally what I get it. So for that, how many classes should be used, and then how should the endpoints of intervals be determined, and then how many class intervals are going to be displayed. So normally many. So many means narrow class intervals or few wide class intervals. So what is the difference between them? So if I'm going to construct many bars, then the class interval should be very narrow, so which can able to yield a very jagged distribution of with gaps from the empty classes, and then which can able to give the poor indication of how the frequency varies across the classes, right? So this should be many. So many graphs are going to be done. So what will happen? It should be all the bar size should be very congested. Suppose if I'm going to construct a few, so what will happen? The bar size should be increased, and then the class interval range should also be more here, wider. So what will happen due to this? It may compress the variation too much and yield a blocky distribution, and then it can also be a bit obscure important patterns of the variation. So these are the sum of these class intervals. So how many, whether it may be many means we have to construct narrow class interval. If we are going to construct few means we have to be wide class intervals. Then, so next, graphing numerical data, that should be a frequency polygon. So how the frequency polygon is going to be obtained? So once I drawn this histogram, so what I drawn previously, so joining the midpoints of the values of the histogram, so becomes the frequency polygon. Okay, so then we have to remove the bar. Then what we are going to get? So I'm going to get this histogram, frequency polygon. Right, so what is the similar thing I have to consider here? This should be 0, and then so what will happen? So in class intervals 10 to 20, frequency is 3, right? So construct 3 here, right? And 6, next one is 6, and next one is 30 and 40 in between 5. So 30 and 40 in between 5, and 40 and 50 it should be 4. 40 and 50 it should be 4, and 50 and 60 it should be 2, right? And this should be 0. Initially 0 in between. So like this, I have to consider histogram, then join all the dots of this, all the center point of the bar diagram. So then after that, once we remove this everything, so what is the line curve what I obtained, that should become the frequency polygon. Okay, now we will see about how to construct this tabulating numerical data cumulative frequency. So for that one already I told, right? So the data what we are going to have, that should be going to be arranged in sorted way. Then we have to split according to the classes, and then we have to identify the frequency, and then percentages we have to be identified. So how the cumulative frequency is going to be identified for that one? So what you have to do is, so identify first one is that cumulative frequency is 3, right? So then add 3 plus 6, how much? 9, and 9 to 5, how much? 9 plus 5, 14, and 14 to 4, 18, 18 plus 2, 20. So like this, I have to calculate the cumulative frequency. After that, what I have to do is I have to calculate the percentage, cumulative percentage. So for initially we have 15 here, so that 15 have to be taken out, and then add 15 plus 30, 45, 45 plus 25, 70, 70 plus 20, 90, and 90 plus 10, 100. So like this, I have to calculate the cumulative percentage also. Then based on that only how to construct this OGU. So OGU is the next way of representing the data. So here based on that, so lower, identify the lower class boundaries between the class intervals. So here less than 10, so 10 how to consider it, and then 10 to but less than 20, so how to consider 20 here. So like that I have to identify all the lower class boundaries and obtain this cumulative percentage here, and then construct the OGU graph by taking the cumulative percentage on y-axis and then class boundaries on x-axis. So this is another way of representing. And next one is that scatter diagrams. So here the scatter diagrams will be another way of representing that. So these scatter diagrams are going to be used for bivariative numerical data. So this bivariative numerical data consists of paired observations taken from 2 or more numerical variables, right? And this scatter diagram is the one which is going to be measured on the vertical axis, and other variables is going to be measured on the horizontal axis, right? So the scatter diagrams are going to be used mainly for bivariative numerical data, so which is going to contain the pair observations and then taken from 2 or more numerical variables. So this is the view of this scatter diagram. So if I consider an application of this like volume per day and then cost per day, so this is the example what I took here. So based on that, I have to take the graph, and then by taking the volume per day will be on x-axis, and then cost per day on y-axis. So according to that, we have to map it. So 23, so 23 for cost per day is how much? 125. So this one I have to mark it out, and similarly for 26 it should be 140, and 29 146, like this. So in scatter diagram we have to only put the dots for the corresponding value. So like this I have to construct this scattered diagram. And how we're going to construct this scatter diagram in Excel, I have to explain now. So for this, open the Excel and then select the wizard of the bars, and then select the next option. So here we are going to have XY scatter. So try to select this, and then we can able to obtain this scatter diagram. So what way we have to get it? That one you can able to done through the Excel.
Like, share and subscribe. Hit the bell icon for more updates.